Hi guys, so today we're going to be talking about systems of equations and systems of inequalities. So you might be wondering, what is a system of equations? Systems of equations are two or more equations. Actually, you can have as many as you're comparing, that share variables. So in all of the cases that I've done as examples, the variables are x and y because we're most familiar with those. And so I'm going to show you a few different ways, because there are three different ways that you can solve these, by graphing, by using the system of substitution, or by doing elimination. And then I'm going to explain a bit about how to graph systems of inequalities. So the way that I'm going to show you how to graph, rather than trying to graph and get very, very precise decimal points on the graph paper that I've used as my background, because that would be really difficult and probably pretty inaccurate, I'm going to show you how to do it digitally through the software program Desmos, which is free to use and extremely user-friendly. So you're going to want to go to Desmos, and I'm just going to blank those out because those aren't the ones we're dealing with right now. And for our first problem, you go to desmos.com and type in the equation that you want to do. So I've already typed in all of the equations that we're going to be using Desmos with today, but I'm going to go ahead and highlight the ones that we're doing right now. So for this first problem that we have, we don't even really need to worry about making it into standard form or anything like that, because the computer does that for us. And what you're looking for is where these 2 points are intersecting, because that's where they're sharing values, and that's what you're looking for in this, is where they are the same, essentially. So my points have disappeared. Here they are. So if you hover over with your little pointer, it'll show you the points for each of these things down to the decimal, which is extremely nice. So I'm going to go ahead and show you another example on here of how to do this. So these are linear equations, which something that I would always recommend is having an idea of what these equations are supposed to look like whenever they're graphed. So, maybe you accidentally squared something that you shouldn't have, or didn't square something that you should have. Then you'll be able to look at it and say, wait a second, that doesn't make sense, and recheck your work and recheck what you've typed in. So for our next one, we have a parabola. So you're going to have a little U shape, because it's positive. If it were negative, then you'd have a little upside down U, an N, I guess. And then for this, it's a cubic function. This is raised to the power of 3, and this is squared. It's going to look something like this. It's going to be a little wiggly. Something also to note with these systems of equations is you may have more than one point where they are intersecting, which I believe happens with this next example. So let's go to it and find out. So I'm going to click on both of these. Something also to note about Desmos is to type, to bring it up, to bring it to a power, all you have to do is, once you've typed an X on your keyboard, you'll hit the shift and you'll hit 6, and that's the caret key, and then you can type in whatever number you need to put there, and then use the side arrow to be able to click off of it, so you're not typing the rest of your equation down there. So like I was saying, on this particular example, you'll see your cubic is doing like this. If I zoomed out more, you'd be able to see the top of that. And your parabola is doing exactly what it should be doing. So you'll be able to hover over and see the 2 points where it's intersecting. Oh, excuse me. It's not intersecting right here. It's intersecting here, and it intersects up here, and kind of sticks together a little bit. I don't know if I'll be able to zoom out all the way, but you can see this gets very thin, but it is making that cubic shape. So the next thing that we're going to be looking at is an absolute value equations. So absolute value equations are kind of similar in shape to parabolas. They do this little V thing. And what's important to note about absolute value equations is this number that's inside of the absolute value signs, it's kind of going to do the opposite of what you would expect it to do. So if this was just the formula y equals x minus 5, you would expect, little graph thing, and it would go in the negative direction over here. However, because it's inside of the absolute value symbols, it's gonna react similarly to how it would if it was inside of the parentheses. So it's gonna move to the right rather than to the left, even though it's negative. And you'll see something whenever I turn on the graph, like these. And then this one in particular was a little bit more complicated, and on absolute values especially, I find it's easier to graph them because, especially on a program like Desmos, because then you don't have to worry quite as much about the absolute value signs, because that can be a little bit confusing and hard to visualize without a graph. So then you can see the 2 points where it's intersecting right here and right there, and you'll be able to write those down for your answer. Okay, and I'll be coming back to these whenever we talk about systems of inequalities. So the next method that you can use in order to find answers for your systems of equations is substitution, the substitution method. This is one of my preferred methods just because it's kind of the same every time, in a sense. So let me zoom in a little bit more on this first one. So these are the two equations that we're working with. So whenever you get something like this, for me, it's easiest to look at it and say, okay, which am I going to plug into which? In this case, I have chosen to substitute. See, this is saying your y is equal to this. And you want to be able to solve it, and to be able to solve it, you can only have one variable in what you're solving. So what I did was I wrote out the second equation, and I substituted in for the y this first equation. So as you can see right here, I did this. Then you distribute the 15 to each, combining like terms right there, then dividing these numbers by 5. Before you divide by 5, combining like terms, once you've simplified it as much as you can, then dividing by the 25, and you'll get x to be negative 17.2. Then you can decide which equation you'd like to substitute this x in. It doesn't matter which. Something worthy of note, which might get confusing, is let's say I wanted to solve out this equation for the y. I could not take what I solved this y for and plug it back into the same equation to find out what y is, because that's not solving your systems of equations, that's just looking at one equation. So then you plug your x into the equation that you choose. In this case, I've chosen the first because it was already a y equals, so all you would have to do is work on one side, distribute, add them together, and you get y is equal to negative 7.4. If you wanted to write this as a as points for your graph, you could write it like these. Bum, bum, bum. And then you've got it. So now let's get a little bit more complicated. So now, rather than having two linear equations, which are fairly easy to work with, as you can see, that was just really simple, like addition, subtraction. Now we're going to get into something a little bit more tricky. So this would be a parabola, and this would be a little funky function like this. And so what I did here was it's the same process though. So what I did here was I took my y and I plugged it into my y of this equation. I distributed my x, simplified it as much as I could. This, however, is not something within our mathematical skills that you can't factor this, you can't use the quadratic formula on this, so you really don't have any other choice but to graph this. And for this problem in particular, like things like this, I find very difficult on Desmos to really break down and be able to see where each of my points are. So for this one, I did it in my calculator, and here are the instructions on how to do that. So you'll click on your little y equals button on your calculator. I've gone ahead and pulled up an image of a TI-84 calculator just so that I can kind of show you on the calculator itself where these buttons are. So you'll hit right here the Y button, and that is going to pull up right here. It's going to say like Y1, Y2. All you need to do is type in whatever your equation is right here. So there I would type in this. Then next I would hit the enter button right in the corner right there. You probably already knew where that one was. Then you'll go to your graph so that you can see what exactly it looks like. You'll hit the second button, which is right here, this lovely blue one, and a few options will come up on your screen, and it'll be like 1 something, 2 something, 3, etc. And your second option is going to say 0, and that's the one that you're going to want to go with. So you'll click enter on that, and then you can use these controls right here to be able to navigate on your graph. So now I'm going to show you what that graph actually looks like itself. Just give me a second. And this is what your graph is going to look like once you've done all of those steps, and you'll be able to move these around. Now you can see that you have a few different points that are intersecting your x. So all 3 of those are important and valid points. So you're going to have to use all 3 whenever you're substituting back into your equation. And what I mean by this is write down, so you'll be able to use those controls to get onto each of these 3, and these are those numbers that I've already pulled out. So then you'll take your equation. In this case, I just used the second equation right here, that xy equals 16, because it's the most simple. And I just divided 16 by each of these x's individually to get what each of these would be. So if I wanted to write these as points on a graph where these 2 lines are intersecting, which you could also check by where it has the y equals, moving down 1 and typing in the equation of the second on there, and actually looking at them on the graph on your calculator, but we're not graphing here, we're substituting. So if you wanted to write these out, then you would just do your x comma your y, and you'd be able to see those points. So once again, a little more complicated, and our last example of substitution that we're going to do is, this is an absolute value, and this is another quadratic equation. Okay, so this, like, looking at it, you're just like, oh, that's disgusting. And it can be really confusing, so we're going to break it down. So both of these are already set equal to y, so that means that you can set both of these equal to one another, because in reality you're just taking this and substituting it for the y right here. So then you're going to simplify as much as possible. So your 5 minus 3, to get rid of this 3 right there. Then you'll just have this is equal to this. Now, Now you have, you've isolated your absolute value. Um, and so this x can be either negative or positive. In this case, I just solved it for the positive aspect. So then you take this and you move it over and you simplify things as much as possible. And this is not factorable in like the traditional sense of things. So you would try and pull out your x, and because this doesn't have an x, I put it right here and then took the rest and factored that. And what's really great about this is all of these factors, all of the zeros were the same. So it was all x equals 1. Then all I had to do was take that x equals 1 and put it into one of the original equations. So I took this first one and did it. And I got y to equal 11. So now we're going over our next way of solving this, which is elimination. So elimination, different from substitution or graphing, is you're not exactly changing the equation, but what you're doing is you're multiplying it in a way that's going to get one of your either your x or your y to cancel out so that you'll be able to solve it. So what you do is almost like you were doing like a matrices for systems of equations. You want everything in the same order. So I made these both y equals from their original equations and set them up where the y's and the x's and the extra stuff were all next to each other, all in a line. Easy. To find what, so I wanted to cross out this x. So to find what was going to make that x cross out with the 5, because it's like you're adding, so you're adding these two equations together, but whenever you multiply by a negative, that adding becomes, subtraction in a way. So you multiply this by what is going to make this number 5, and then all of these get multiplied by this number. So as you can see in this next part, I added but with negatives, so subtracting, and then simplified everything and divided, and then y was equal to negative 10.77, and then you take that y and you substitute it back into your original equation. So not the one that you multiplied into being something kind of different, just your original. And you plug it back in for where your for where your y would be, and solve for your x, and then the x was equal to negative 7.14. And if I were, let's say I had taken all of these equations that I've been going through and would have done them, all 3 of the methods that I'm showing you right now would give you the same answers. The only difference is just in the method that you're using, obviously. And sometimes just like certain equations are so much easier to do in one method over the other, or sometimes you really don't have an option of how you're going to be able to solve something. So it's very important to understand how to do each of these equations in whatever way is necessary. So our next equation that we come upon is these. So like these would be parabolas. And so I made them both into y equals. Though I did just leave this one as the 2y because I didn't want to make it, it would have made it more complicated to solve if I would have divided, because I would have had to, then I would have had a 1/2 x squared plus a 3 over 2, and you don't want to make it more difficult. You're trying to make things as simple and as easy as possible for yourself. So then, like I said before, you are adding these equations even though it kind of doesn't look like you are. So, this one was very simple because of the way that these worked out is this x squared and this 3x squared canceled out without actually having to multiply by anything, just because they were the opposite sign of what was in the original equations. Hold up. Sorry guys, I just realized that I had written the wrong number here. I had a 3 here, but it actually should have been a 2, so I went in and I fixed that. Because then these will cross out, and oh my god, and then these will be added together, because remember, this is adding. So you'll have a 3y, and you'll have a negative 6, and so your negative 6 will be divided by that 3, and you'll get y is equal to negative 2. Then I substituted the y as negative 2 into the equation. So I substituted it into this equation right here. And, so the y became this negative 2. And once you simplify it, so this 2 gets moved to over here. You know, does that make sense? Yeah, you understand. I realized, oh, this is not factorable. So, that means that we have to break out our old friend, the almighty formula. The quadratic formula is such an important formula to remember for literally like everything in math. You can use it in physics and math, whatever. If you're having something that is not vectoring, use this. So I went in, I labeled each of these what they are in this formula, and you just plug it in. Then I break this down by step right here, and sometimes you'll want to leave your answer like this, and that's all you need to do. You don't need to make it into a decimal because this is already simplified, but it's important to remember this is a plus or a minus, so you have to do both. So here's the plus, here's the minus, and here's the 2 different x's, and because you only have one y, that y goes to both. So now our third and final example of solving systems of equations before we hop into systems of inequalities is this one, which is another absolute value example. So this one I just simplified into this y equals, then added them together. Once again, that x canceled out, and so I just solved for y, got y is equal to 8, so put that 8 back into the formula for the y, and because this is absolute value, you have to do the negative and you have to do the positive. So this is what I got for the positive x, and this is what I got for the negative. Now we're going to hop into systems of inequalities. So there's a few very important things to remember for systems of inequalities. So for systems of inequalities, what you're doing is you are graphing these lines and you're finding out where what they say is true. And what I mean by this is you have your greater than and less than equal signs. You're looking for where this is actually true, that it's greater than or it's less than whatever number. So for me, everything is easier whenever it's in standard form and I can see where my y's are. So I did that. And another important thing to remember about these is that if you have a line underneath of this, the line that you draw is going to be an actual line, and if there's no line, then it's going to be a dotted line. And you can see that in what I've done on this graph. So you just simply graph by as you always would, taking your slope and your x-intercept. So I just made this by 2's. You can't see it anymore because I've highlighted making the thing over this, but you'd be able to see that this is by 2's. So trust me, this is actually spaced evenly. And this one didn't have a line underneath, so I dotted its line, and it had a positive slope, so it's going up. And this one has a full line because it has a line underneath. So now you're like, okay, but how do you know how you're shading? Well, if you're in this side, you're going to shade above. You know, if the y is greater than blah, 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 then you're going to shade above. If it's less than, then you're going to shade below, which just kind of makes sense. So I did that for both of these. And this part, where it's kind of this purpley gray, is your actual answer. So if you wanted to, I could have, or you wanted to, you can erase this, because this is all that you're actually looking for, is where those two are making sense. So the next one that I had is this is a parabola, and this is another one of those absolute value equations. And all these were is really simple, and then just little shifts. So this plus 5 meant that my parabola was moved up 5, and this plus 7 meant that this was moved up 7. So I gave it a little shady shade, and this is where they're both true. So our next example that we're going to work with, I'm actually going to show you on Desmos, because it's easier to see there than if I was just doing it by hand. So we're going to hop on over to Desmos and click these. And it would be the exact same method of typing in this. You have these little symbols on your thing. To get to the pi, down here, it's actually out of frame of my video, but down here there's a little keyboard, and you click on it, and it has a little pi symbol, which is also out of frame of my video, but it's down there, and you'll be able to click on it, and then just hit your little /, and you'll be able to make your divide by sign. Easy peasy. So then now you can see where these graphs would be together, and how would they react with one another. So now, we're going to talk about how you would actually use these things in real life, which is a question all math teachers get a lot. I'm not one, but I know that they do. And firstly, I'd like to say that math isn't really something as a subject that's only use is directly using these things in real life. It's a way of looking at the world, and just treating it as another lens can be beneficial. But ways that it is really used, is so profit comparisons. If, like, let's say year 1 is represented by one equation that looks like this, you might have year 2 as an equation that looks like this, and you would be able to compare them like that. Tracking change is another thing. So you can track your change in profits of each week or something like that. And you're always looking to find solutions to problems that you're facing, and finding that sweet spot between too much or too little of X amount of things. And you can use these equations to do so. So I thank you so very much for watching, and I hope that you've learned something today.